Very good morning. Welcome you all to the NPTEL course on Advanced Distribution System Analysis and Operation. Now, as on today, we have covered most of the distribution system analysis and its operation part. However, you all might be surprising that why it is so called Advanced Distribution System Analysis and its operation. You'll be very happy starting from lecture number 51 to 55. Truly, in a sense, we'll be touching upon the latest technology for distribution system analysis and its operation, and we'll thoroughly discuss each and every aspect of advanced distribution system analysis. Hence, I request all of you to be, quite sincere in understanding lecture 51 to 55, because most of the contents are not available in a regular textbook. So the contents which are available in any one of the regular textbook on distribution system analysis and operation do cover the basics, but we will try to cover up some of the latest technology which is available in the form of literatures and online materials. And hence I request all of you to take sincere notes and try to understand the new concept on advanced distribution system analysis and its operation thoroughly. In this module, basically, we'll be talking about overview of advanced distribution management system, popularly known as ADMS. Then we'll be getting into advanced metering infrastructure, popularly known as AMI. Then we'll get into smart meter data analytics. This is an important concept because the smart meter is not only responsible to give you the energy unit being consumed by a customer, but it is also responsible to carry out at least a bit of analytics so that certain decisions can be taken, and it will be quite responsive to the substation or the SCADA system in future. Then we'll move to operation of distribution phasor measurement unit, which is also called DPMU. So this is also an important concept. So we know transmission phasor measurement units, PMUs, and we'll also focus on how distribution phasor measurement units can help us to make our conventional distribution system more effective and more smarter. And then at the end, we'll get into distribution network restoration mechanism, that is the last content. Now moving to overview of advanced distribution management system, so-called ADMS. Now in smart grid era means to me it is the current modern power system that we are talking about. In smart grid, according to Department of Energy, DOE USA, Advanced Distribution Network Management System, ADMS, incorporates conservation voltage reduction, that is CVR, load management, LM, and fault clearing topologies to ensure reliable, efficient, and secure operation of distribution network. Now, the definition of ADMS that vary from author to author, region to region, similar to smart grid definitions. But one thing is very clear, this has the feature of CBR, LM, and also clearing topologies to ensure reliable, efficient, and secure operation of distribution network. The concept of ADMS has evolved over the past decade, which is a very, very latest topic. Recently, 5 to 10 years, people started talking about ADMS. Similar to how the smart grid definitions have changed, the definition of ADMS also changed over a period of time. But ADMS is no longer seen as a fixed set of tools, but as a flexible approach to modernize grid operation. So ADMS is basically making your distribution grid modern. Now it combines various components such as outage management system. Your ADMS has the capability to take care of outage management system. It do have actually supervisory control and data acquisition, SCADA system. Distributed energy resources management system, DERMS. mobile and advanced application from single or multiple vendors. Now, according to Pacific Northwest National Laboratory, ADMS provides operational and analytical tools for dispatchers. It helps to manage assets and process near real time data efficiently, prepares utilities for high DR penetration and transactive load environment. Now, ADMS, which is also capable of integrating previously sealed utility functions into a common platform with well-defined interfaces. Now, it also ensures functionalities, interoperability, and structured interaction between different systems. Now, as per Gartner, ADMS is a software platform supporting the complete suite of distribution management and grid optimization tools. It enables automation of outage restoration and performance enhancement of the distribution network. Now, let us get into the complete architecture of ADMS. So, we'll be focusing on the whole architecture system here. So, first of all, before we move forward, I will try to explain the complete structure here about ADMS. Now, let us understand DG is distributed generation, RTU represent remote terminal unit, AMI represent advanced metering infrastructure, MDM represent meter data management, CIS represent custom information system, SADI system average interruption duration index, SAFI system average interruption frequency index. Now, what happens? There are different features or tools available within the ADMS. So, some of them are distribution network analysis. So, when you talk about distribution network analysis, now it has certain software tools, so called state estimation, power flow, fault location, load allocation, limit monitor, power quality, short circuit, loss analysis, load model and forecast. So, these are the kind of features any distribution operator can exercise within distribution system or distribution network analysis part. We also do have panel fault isolation and restoration, feeder reconfiguration, outage study, load and volt var management. These are all complete features. Then we can move to the outage management part. So, there actually unplanned and planned activity for outage management, then trouble call management, crew monitor, calculate SADI and SAFI and other functions. Now, we can also move to switching operations, which is creation and validation and execution of switching orders, creation and management of safety documents, and also one more important component known as training simulator, which takes care of distribution operators training programs, outage and restoration training, operation validation tools. So, what I wanted to highlight, so these are the input tools available to my ADMS, and depending upon the application and requirement, certain algorithms can be run and being carried out. Now, when we talk about distribution network operation model, which is an interface, user interface, and we have actually database resource model. So, the user interface basically takes care of topology analysis, energization status, and tagging, loop detection, operation nodes, and network tracing. However, the database resource model takes care of your support real-time updates, equipment connectivity impedance model, DG load models, and maintain static and dynamic data. And you will also have other supports through your GIS system get connected, CIS system got connected, field operation data, AMI MDM data, and corporate and back office interfaces possible. And finally, you will have a SCADA system. That SCADA system also interfaced, which is responsible for monitor and control via RTUs and data acquisition devices. which is responsible for training, alarming, logging, and RTU scanning. So this is whole. It's a big information that are available to ADMS with different tools connected and actively being part of it. But none of the distribution system necessarily will have actually every component in place. But anything related to this diagram that I have, high level functional architecture that you have seen, will be a part of your ADMS system. At the end, I will talk about the what portion of ADMS available to IIT Roorkee campus, that I will discuss actually during end of my lecture. Now, when you talk about what are the benefits and why do we get into ADMS, that's one of the very common question any student can feel like raising this question. So ADMS, which integrates SCADA, outage management, switching, and advanced application into a single solution, and operated through a unified user interface, that is UI, and user experience, UX. It offers operational convenience, fewer system transactions, less manual data integration. It enhances safety, operational efficiency, and reduces user stress and data errors. It improves situational awareness by providing a centralized view of the network. Now, we can also get into the functional architecture from the figure number 51.1, which illustrates the architecture. It is native interoperability between outage management, switching, and network optimization via the distribution network operator model, so-called DNOM. Now, the DNOM is a physics-based model representing the full power distribution system. Now, if you see the top layer of the advanced applications and operation, we will have actually outage system in place, that is outage management, switching operations, and advanced applications. Now, within outage management, which handles detection, classification, and restoration of outages, which integrates with smart meters, call centers, and SCADA. Now, in case of advanced application, power flow analysis, fault location, state estimation, bolt war optimization are being carried out. Feeder reconfiguration and load forecasting for operational planning is also comes under your advanced application. Now, in case of switching operation, which enables safe and validated switching orders for planned and unplanned maintenance, includes tools like tagging as well as an operation validations are being carried out. Now, then we can move to the middle layer, which is distribution network operations model, that is DNOM. So, core of the ADMS, which is a physics-based electrical model of distribution system, which supports real-time state estimation as well as voltage analysis and topology processing. And the main purpose, which ensures consistent data across OMS, SCADA, switching, and analytics, acts as the single source of truth for the system state and configurations, which includes phasing, three-phase, two-phase, single-phase, neutral ground connections, switch states open or close, and impedances and connectivities. Now, we can slowly move to the last and bottom layer. Because if you go through the diagram, as you could see this diagram, all of you please focus on. So, we have a top layer, the middle layer, a top layer, and then we come across the middle layer and the bottom layer. Okay. So, we move to the bottom layer. So, in the case of bottom layer, we have actually GIS, okay, Geospatial Information System, and then we have CIS, which is Customer Information System. Then we have AMI, MDM, which is Advanced Metering Infrastructure and Meter Data Management. Then we have SCADA, then Field Operation Systems, and finally Corporate and ERP systems. So this is what actually falls under my bottom layer, or data sources and external interfaces. Now let us try to understand the data flow and integration. Now if you start understanding the top down, okay, and then we can think of actually bottom up. So top down actually we consider actually operational decisions, example switching, load dispatch, flow from ADMS application to field devices via SCADA or other control systems. Now in case of bottom up, we'll talk about field measurement, meter events, GIS data and outage reports, update the DNOM and trigger ADMS functions. Now, when you talk about operator interface, which is a single unified interface, allows operators to view the network model, perform switching, monitor alarms and faults, and execute restoration and optimization plans, which mainly reduces the need to jump between multiple software systems. And moving to interoperability, the architecture promotes native interoperability, ensuring real time coordination across fault location, reassignments, voltage management, and outage analysis. Now, real time model updates reflect changes in switch status, outages, or field interventions. Now, this is the distribution operational function pyramid. There are different layers actually. So you could see the blue color. There are three layers which talks about the static view of network configuration, ability to operate networks, and customer status, which are called so-called trouble calls. And almost all the distribution system today do have these basic functions. Okay, so one, two, three, they are known as my basic functions. And then further, if you move up and up in the pyramid, which is known as advanced functions. So remote control and monitoring, that is your SCADA, is one of the advanced system. So currently IIT Roorkee has adopted SCADA system into its academic campuses. Then we have outage management prediction analysis, then network visualization tools, power flow analysis, study model tools, and finally network optimization. So these are the five different functions make your distribution operation more advanced type. Now, in case of figure 51.2, which talks about 8 layers of the pyramid, where 3 of them are very basic models and 5 of them are actually reasonably top models, which depicts hierarchy of ADMS functionalities from basic capabilities at the bottom to advanced application at the top. Top level represent advanced applications like optimization and power flow analysis. Bottom level reflects basic functions like SCADA monitoring, trouble calls, and static network views. Now, when you talk about common network analytics functions, we have to, have those features within which the first one normally which is available to us is power flow of state estimation, and then we have actually short circuit analysis, fault location, as well as loss and limit monitoring. And these are the features, those falls under network analysis functions. Now we'll move to the network optimization functions. So when you focus on network optimization function, which solves the same system equation but optimize settings of controllable equipment to achieve objectives, such as reduce voltage and thermal violation, which can also try to minimize losses and energy consumption, which maximize service restoration after the faults. And controllable devices includes tap changing transformers, so we can change the tappings of a transformer so that certain features can be or certain objectives can be met. We can operate the capacitors with different switching operations. You can reconfigure the switches, okay, whether to open or on. And then finally the DR inverters for PVs and batteries. Now, what are those historical challenges in implementation? because as of now, what we have seen, ADMS seems to be very much attractive, which has the modern features, make your distribution system more robust and resilient. But what are the challenges? There are bit of issues that need to be discussed. The first one is the limited deployment. That means most utilities only achieve the bottom three levels. However, SCADA, outage management, and basic visualization, most of the cases you may find. However, few utilities have implemented or actively use advanced applications. Very few distribution systems in the country or the globe do use such advanced application. So that means we do have limited deployment. Most of the distribution system across the globe and the country, including most of the urban cities of India, we do not have the complete ADMS application as on today. Now, technical challenges. What are those challenges? Model complexity, because thousands of equation on par with transmission level analysis need to be carried out. It's a huge computation. Data quality issues, errors in DNOM, distribution network operation models, due to incorrect equipment specifications, incomplete GIS data, field configuration mismatches, example, manual switching not logged, and equation convergence, which is advanced apps must solve nonlinear equation, which may fall if the model or data is poor, because in distribution system is so huge because of residential customers, industrial customers at 11 kb. It's so huge. Getting the accurate data from time to time become a huge task, and algorithms must be numerically robust to tolerate data errors. So anything that we carry out must have the trust with the data set, and also in a position to quickly take action and give you solutions how the distribution system is expected to operate. Now, what are the recommendations for success? I strongly recommend the cited references. Please take a printout and have a look. That will help you to understand few more informations that has not been discussed. So it employ automated model validation tools, ensure continuous model maintenance, especially with field updates and DRs, build organizational support and cross-functional collaborations, prioritize phased implementation over big bang rollouts, use DOTs, distribution operations training simulator, to train staff and test the system safely. Now, slowly let us move to a very important component of distribution system ADMS, so called supervisory control and data acquisition, that is SCADA. So, SCADA stands for supervisory control and data acquisition. By the definition itself, it is responsible of getting all the information from your distribution system at each and every substation locations. Am I right? And it is a centralized system used for monitoring, controlling, and automating industrial processes, including electric power systems. So, SCADA is a foundational component of ADMS, which is a comprehensive platform for managing modern smart distribution networks. Now, what is the effectiveness of SCADA in ADMS? So, when you talk about ADMS, which is a larger umbrella and within which we have actually SCADA, how we see the effectiveness of those SCADA operation in your ADMS system. So, real-time monitoring and control. So, SCADA enables operators to view and control the distribution network in real time. It supports fast decision making for fault isolation, load balancing, and restoration. Data collection of analytics, that is, provides continuous data streams to state estimation, fault location, and demand forecasting tools within ADMS. Now, integration with automation, which supports distribution automation by sending control commands to automated switches and reclosers, which helps enable self-healing grid resilient through fault detection and reconfiguration. So, these are the advantages of having a SCADA within your ADMS system. Now, we can also have alarm and event management. So SCADA generates alarm for abnormal conditions. Example, if there is a voltage, normally, let's say campus life, the voltage is expected to be close to 230 volt in India, single phase. However, if it is 250, 260, 270, then certainly we'll see some alarm which is coming within your SCADA system. So the operator in the screen can easily come to know there is an issue, and probably certain remedy or solutions can be carried out, which are essential for situational awareness. And communication backbone acts as the communication layer for RTUs and intelligent electronic device IDs across the network. So let's say each and every substation of our academic campus do have RTUs, and those data, those RTUs keep on sending the information so that the operator in the SCADA room can easily see what is happening to my devices located bit far, and the information available to me through RTU can be analyzed and observed. Now, there are a bit of issues also, because SCADA is a good thing, but there are also a bit of limitations of SCADA in modern distribution systems. Now, low data refresh rate, that is typically second to minute, makes SCADA insufficient for high speed transient event detection, because SCADA is not that fast actually. So it takes reasonably few seconds to carry out operations. So if you like to have actually very fast actions, then these are the issues the SCADA may face. And the non-synchronized measurements, which limit accuracy for advanced applications like state estimation or event localizations, lacks the granularity and resolution provided by distribution PMUs or AMI systems. Now we'll slowly move to IIT Roorkee SCADA overview. So very soon, I'm very happy to say that the SCADA system which is in place, and I'll be very happy to share that actually, my close association with SCADA installation made me very happy the way IIT Roorkee campus is currently made its distribution system quite modern. Though it is not an ADMS, but certainly I can say we are in between a conventional distribution system and an advanced distribution management systems. So this is the IIT Roorkee SCADA system, and we have actually, communication network for IIT Roorkee which is in place, and 33 by 11 kV substation data which is available to us. And these are the different substations, we name it as a bin tunnel, earthquake engineering department, Kasturba Bhavan, high voltage lab, AHEC, RK Bhavan, Vikas Nagar, Bigyan Kunj, MGCL, okay, and then VIP areas, Canal View, Niti Nagar, workshop area, Biotech, Rajendra Bhavan, MAC, STEP, Hillview, WRL. So these are all, IIT Roorkee communication network which is available to me, and all the information, they are being fed to the SCADA system from time to time. So if you see the IIT Roorkee SCADA overview, 11 kV. So I was very keen when a system is available to us, let my students and practitioners must have bit of hand-on experience. Though it is an online course, but I thought let me share some of the screenshots. So this is how it operates. So you could see that 11 kV overview, and we do have actually diesel generators which is connected here, DG incomer. We have DG incomer, we have 11 kV substations, and there are two incomer, main incomer 1 and main incomer 2. And then further you can see that there are so many other locations of the substations as we talk about actually Vikas Nagar, VIP area, Rajendra Bhavan, WRL, Vigyan Kunj, high voltage lab. So these are the areas actually where they have been connected. This is Canal View, this is Wind Tunnel, and this is Biotech, and this is MHSS. So these are different areas how the flow happens in a distribution system of IIT Roorkee campus now. So you can clearly see all the switching systems, all the capacitor banks, all the feeders connected from the 11 kV overview of the complete network. Now, once we come to 11 kV, then we have taken a small Bigyan Kunj control room where from the 11 kV, we that spreads out to different locations. and some of the snapshots where we measure the voltages, three phase, then we measure the currents, I1, active power, reactive power, apparent power, and power factor. You could see everything is available to me in real time. And the same thing happens at each and every feeder level, wherever you want. So what I wanted to highlight, the SCADA system will really make all the data of the distribution system available to me. So if I have to carry out any analysis based on this information, probably I'll be in a position to demonstrate and do it. So with this note, I like to thank you for your wonderful attention. And this lecture is really important because which is something very interesting. And if you get opportunity, please visit your nearby SCADA stations and SCADA control rooms and try to understand the functionalities of a SCADA system. And if possible, you can also visit to a new modern distribution system which has incorporated the complete ADMS as on today. But to start with, I will strongly recommend to visit a distribution network which has accommodated SCADA integration and successfully being carried out data transfers. Thank you.